Imagine attempting an instant crypto payment, only to have it fail, not because you lack funds, but because the network's geometry literally forbids the math. This presentation explores a mathematical theory of payment channel networks, which explains why this happens. The Lightning Network scales Bitcoin, yet it faces two key reliability problems: channel depletion and mathematically infeasible payments. The authors argue these aren't just software bugs, but structural consequences of how two-party channels constrain network geometry. To understand these constraints, the researchers model the network as high-dimensional geometric shapes, called polytopes. They distinguish between the internal state of channels and the actual feasible wealth distribution of users, linking them through a mathematical projection. Using this geometry, they derive a fundamental throughput law. It states that the sustainable off-chain payment bandwidth is strictly limited by the underlying on-chain transaction rate and the probability of payment infeasibility. The paper then compares how fee structures affect this geometry. Experiments show that standard linear fees drive channels to deplete completely, whereas convex fees, which get more expensive as funds run low, force the network to stabilize near a healthy, balanced center. Beyond fees, the theory points to a structural solution: multi-party channels. The math demonstrates that increasing the number of participants in a single channel strictly expands the geometric region of feasible payments, significantly reducing failure rates. However, limitations remain. The set of possible off-chain payments will always be smaller than on-chain possibilities. To mitigate this, the authors propose coordinated replenishment protocols that actively move liquidity back to the geometric center of the network. Ultimately, this paper reveals that payment reliability is a geometric problem that requires structural solutions like convex fees and multi-party channels. For more deep dives into network theory, verify the details at emergentmind.com.